Okay, so the prime factorization, again, basically tells us the building blocks that make up a number, and that can give us lots of clues about what makes up that number, or also how that number composes other numbers. So if I want to look at the prime factorization of any multiple of 24, so multiples of 24 are any number that is 24 times something. So multiples of 24, 24, 48, 3 times 24 is 72, 96, 120. Okay, so these are all multiples of 24. So 24,000 is a multiple of 24. Whatever 24 times 17 is. Okay, there's also negative multiples of 24. So negative 720 is a multiple of 24. 0 is a multiple of any number because I can write it as 24 times 0. Okay, all of these numbers are multiples of 24. Okay, and one of the things about the prime factorization is if I can write any multiple of 24, so any multiple of 24 looks like 24 times something, right? And if I want to look at the prime factorization of this multiple, well, that's going to give me the prime factorization of 24 and the prime factorization of that number. So if I know what the prime factorization is of 24, I can say any multiple of 24 is going to have those same prime factors in it. So 24 we saw before. This is 4 times 6, which is 2 times 2 times 2 times 3. Okay, so any multiple of 24, again, let me just reiterate, any multiple of 24 is 24 times whatever, which is 2 times 2 times 2 times 3 times whatever, and you can expand that into its prime factorization. Okay, that tells us that every multiple of 24 contains three factors of 2 and a factor of 23, a factor of 3. And possibly some other stuff. Okay, so, I mean, the three factors of 2 and a factor of 3, that is 24. Okay, that's kind of, you can even take it as a definition of 24. And in order for another number to contain 24 as a factor, it has to contain that. All right? So taking this to common multiples, this can be helpful. So if I want to find all common multiples of 24 and 60, one way to do this is to look at the prime factorization. So 24 we saw is 2 times 2 times 2 times 3. 60 is, let's see, 60 is 10 times 6, which is 2 times 5 times 2 times 3. So it looks like 2 times 2 times 3 times 5. Okay? So any common multiple of 24, well, remember, any multiple of 24 has 3 factors of 2 and a factor of 3. And any multiple of 60 is going to have 2 factors of 2, a factor of 3, and a factor of 5. Let me write that. Any factor of 24 must contain 3 factors of 2 and 1 factor of 3. And I should say, should contain at least 3 factors of 2 and 1 factor of 3. Okay? And any factor of 60 contains at least all of those factors of 60. So 2 factors of 2, a factor of 3, and a factor of 5. So that means that any factor of that is any multiple of 24 and 60 has to contain all of these things. So any multiple of 24 and 60, so any common multiple must contain, well, in order to be a multiple of 24, it has to have 3 factors of 2, and it has to have a factor of 3. In order to be a factor of 60, it has to have 2 factors of 2 and a factor of 3 and a factor of 5. Well, we've already written down 2 factors of 2 and a factor of 3, and we can write a factor of 5. Okay? And so this basically covers all of 24. So this covers 24, and these 3, these bits cover 60. Okay, if you multiply this out, this is 120. So that actually says that any common multiple of 24 and 60 has to also be a multiple of 120. So 120 is the least common multiple of 24 and 60. Okay, and that's basically saying this statement here, any common multiple of 24 and 60 has to contain at least these factors, which means it has to contain 120 as a factor. Okay, now we can put this to use. So again, looking at the least common multiples of a number, you can basically do this just through the prime factorization. So I don't know what these numbers are. I don't really care. The prime factors basically tell me everything that I need to know about them. So I can look at this and ask, okay, so what's the least common multiple of these two numbers? So in order to be a multiple of the first number, this says you have to have at least 3 factors of 2, a factor of 3, and 2 factors of 7. And in order to be a multiple of the second number, you have to have at least a factor of 2, 4 factors of 7, and a factor of 19. Okay, So the least common multiple is going to have to be, well, you can just start writing these factors. I need at least 3 factors of 2. I need at least a factor of 3 and 2 factors of 7. In order to be a multiple of the first number, this is the minimum. Okay, in order to be a multiple of the second number, I need at least 1 factor of 2. I've already got that covered from what I've written down from the first number. I need 4 factors of 7. Here I've written down 2 factors of 7. I need at least 4 factors. Okay? And I need a factor of 19. Okay? So the factor of 3 here and the extra factors of 2 are kind of superfluous to the second number. And I have the extra factors of 7 and the factor of 19 are superfluous to the first number. Okay, so this is my least common multiple of the 2 numbers. It's the minimum that you have to have in order to be a multiple of both of those numbers. Okay, and putting this to use, one of our primary uses of least common multiple is going to be finding common denominators. If you want to know which fraction is greater, or if you need to add these 2 fractions, you need to have common denominators. And why? So remember, the denominator tells you what size pieces you're talking about. All right, and so here I have 5/12, and here I have 19/42, and 12ths and 42nds are just, they're different sized pieces, and so, you know, having 5 of one and 19 of the other is not really comparable. So you might be able to sort of guess, and hopefully you see that 5/12 is a little bit less than half, because 6/12 would be exactly half. 19/42 is also a little bit less than half, because 21/42 would be exactly half. So it's a little bit hard to tell, like, which one is like more less than half or less than half. Okay, so the thing that we can do is we can give them common denominators, find equivalent fractions to these 2 that have common denominators. Okay, so that we're comparing similar size pieces. Okay, common denominators, we want to find multiples of 12 and 42 that are in common. So we need to find common multiples of 12 and 42. Okay, so again, we can go to the prime factorization. So 12 is 4 times 3. This is 2 times 2 times 3. Okay, and 42 is 6 times 7. This is 2 times 3 times 7. So the least common multiple of 12 and 42 is, well, I need at least 2 factors of 2 and a factor of 3. Those are covered in 42, and I also need a factor of 7. Okay? To be honest, I don't care what this number is right now. I like the prime factorization because it gives me extra information. So 5/12. I know that this piece here is 12, so what I'm missing out of here is the 7. So I need to multiply both the numerator and the denominator by 7. So I multiply both numerator and denominator by 7, and I get that this is equal to 35 over, honestly, I don't care what that number is. Okay, and 19/42, well, 42 is the 2 times 3 times 7, and that is missing the 2. So I multiply numerator and denominator by 2, and I get 38. And the denominator is whatever that is. It's not that hard to multiply out, but the point is I don't care. Okay? And so now we can see whatever this denominator is, it's the same. So I'm counting up the same size pieces. And in 5/12 I have 35 of those pieces, and in 19/42 I have 38 of those pieces. So since 35 is less than 38, we have that 5/12 is less than 19/42.